Space, the final frontier, a vast expanse that stretches far beyond our imagination. In its infinite expanse, a multitude of stars twinkle, each a world of its own. The universe, a grand stage where celestial bodies dance to the rhythm of gravity, is home to an almost inconceivable number of stars. Each one of these stellar bodies, a furnace of nuclear fusion, contributes to the glowing tapestry of the cosmos. But just how many stars are there? The numbers are so large they boggle the mind. Yet understanding this scale, the sheer enormity of the universe, is fundamental to our comprehension of space. It's a journey of numbers, a journey of scale, a journey into the vastness of the universe. As we set sail on this cosmic ocean, let's delve into the mind-boggling math of how many stars there are in space. Our home, the Milky Way galaxy, is a swirling mass of stars, gas, and dust. But how many stars does it contain? This question, simple in its asking, opens the door to a realm of astronomical discovery and mathematical marvel. The Milky Way, our cosmic backyard, is a sprawling metropolis of stars. Astronomers estimate that it contains around 200 billion to 400 billion stars. Yes, you heard that right. Hundreds of billions of stars, each one a glowing beacon in the vast expanse of space. Just imagine standing on a clear night looking up at the sky and trying to count each and every star you see. It's a task that's practically impossible, isn't it? Now multiply that by 1 billion, or 2, or 3. That's the number of stars we're talking about, all contained within our galaxy alone. But these aren't just any stars, they're a diverse collection of celestial objects, each with its own unique characteristics. Some are small and cool, barely glowing in the darkness. Others are massive, burning brightly and fiercely. There are stars that are just beginning their life journey, and there are those that are nearing their end, ready to explode in a spectacular supernova. The sheer scale of these numbers is mind-boggling. It's a testament to the vastness of our galaxy and a reminder of our place within it. We are but one planet orbiting one star in one galaxy among billions. Yet here we are able to ponder these astronomical figures and explore the cosmos from our tiny corner of the universe. As we continue this journey, bear in mind these astronomical numbers. They provide a sense of scale, a backdrop against which we can explore the wonders of the universe. So take a moment to marvel at the grandeur of our galaxy and the countless stars it contains. With hundreds of billions of stars in our galaxy alone, it's clear we're just a small part of something much larger. But the Milky Way is not alone. Beyond its borders, countless other galaxies reside. You see, our galaxy is just one of an estimated 2 trillion galaxies that make up the observable universe. Yes, you heard it right. 2 trillion galaxies, each brimming with stars. Now let's take a step back and try to grasp the enormity of this figure. Imagine a sandy beach, each grain representing a single galaxy. Now picture that beach extended across the entire surface of Earth. That would still fall short of the number of galaxies we're talking about. Mind-boggling, isn't it? But we're just getting started. Let's delve a little deeper. It's estimated that each galaxy contains an average of 100 billion stars. So if we multiply the number of galaxies by the average number of stars in each galaxy, we get an astronomical figure that's almost impossible to fathom. The total number of stars in the observable universe is thought to be around 1 septillion. That's a 1 followed by 24 zeros. To put that into perspective, that's more stars than the number of grains of sand on all the beaches on Earth, but it doesn't stop there. Remember, these are just estimates based on what we can observe. The actual universe may be much larger, potentially infinite, and filled with galaxies and stars beyond our current comprehension. With these numbers, it's clear the universe is teeming with stars, but they are not all the same. Just like people, each star is unique, varying in size, color, and age. And in the next scene, we'll delve into the diverse populations of stars that inhabit these galaxies. From red giants to white dwarfs, neutron stars to supernovae, each has a story to tell, a part to play in the grand cosmic ballet. But that's a tale for another time. Stars come in a variety of sizes, temperatures, and luminosities. Each has its own story to tell. In the grand cosmic theater, no 2 stars are exactly alike, and together they paint a picture of the universe teeming with diversity and complexity. Let's start with size. Stars can range from tiny compact objects known as white dwarfs, about the size of Earth, to the colossal red supergiants, which are so large that if placed at the center of our solar system, their outer layers would extend beyond the orbit of Jupiter. Temperature is another distinguishing factor. It dictates the color of a star. The coolest stars glow with a red hue, while the hottest ones are blue. In between, we find stars like our Sun, which is a yellow dwarf, with a surface temperature of about 10,000 degrees Fahrenheit. Luminosity, or the total amount of energy a star emits per unit of time, is another key characteristic. It depends on both the star's size and temperature. The most luminous stars are the massive and hot blue supergiants, which can outshine an entire galaxy. Now, how are these stars distributed in galaxies? Well, galaxies like our Milky Way are organized into various structures, such as spiral arms, bulges, and halos. Stars are not evenly distributed across these structures. For example, younger, hotter, and more luminous stars are typically found in the spiral arms, while older, cooler, and less luminous stars populate the halo. One fascinating aspect of stellar populations is the existence of star clusters, groupings of hundreds to millions of stars that were born from the same giant molecular cloud and thus share the same age and composition. These clusters are crucial for understanding stellar evolution and the history of galaxies. In the grand scheme of the cosmos, stars are the atoms of the universe, each one unique, each one a clue to understanding the whole. The variety and distribution of stars is truly astonishing. The numbers we're dealing with are astronomical, quite literally. To make sense of them, we need to understand the power of exponents. Let's first untangle what an exponent is. Simply put, an exponent refers to the number of times a number is multiplied by itself. For instance, 2 to the power of 3 is 2 multiplied by 2 and then by 2 again, which gives us 8. This might seem straightforward, but once you start dealing with larger base numbers and higher exponents, the results can be staggeringly large. Now let's apply this to the cosmos. The Milky Way alone is home to around 200 billion stars. That's a 2 followed by 11 zeros when written out in full. In exponential notation, we would express this number as 10 to the power of 11. But the universe doesn't stop at our galaxy. Scientists estimate that there are about 2 trillion galaxies in the observable universe. That's a 2 with 12 zeros behind it, or 10 to the power of 12. Now, if we want to estimate the total number of stars in the universe, we multiply the number of stars in our galaxy by the number of galaxies. In exponential terms, that's 10 to the power of 11 times 10 to the power of 12. When we multiply exponents, we add them together, which gives us 10 to the power of 23. That's a 1 followed by 23 zeros. But remember, these are rough estimates. The actual number could be much higher or lower. Yet, even these approximations are mind-bogglingly large. They serve to remind us of the sheer scale of the universe and how exponents help us make sense of it. With the power of exponents, we can begin to comprehend these mind-boggling numbers. And with that, we've unlocked a new way of understanding the cosmos, showing how mathematics and astronomy intertwine to reveal the vastness of our universe. Scene script. Visualizing these astronomical numbers can be challenging, but let's try to get some perspective. Picture this. Let's say you set out to count the stars in the Milky Way, 1 star per second. It would take you around 25,000 years, give or take a few millennia. That's longer than the entire span of recorded human history, just to count the stars in our own galaxy. But the universe doesn't stop at the Milky Way. Let's expand our vision to the observable universe. It's estimated to contain 2 trillion galaxies, each brimming with billions of stars. If you tried to count all the stars in the observable universe, 1 per second, you'd need more than 300 sextillion years. That's a 3 followed by 23 zeros. To put that into perspective, imagine a grain of sand. Now imagine a beach, a vast stretch of sand extending as far as the eye can see. If each grain of sand on that beach represented a star, you would need countless beaches to represent the number of stars in the observable universe. Or consider this, if each star in the universe were a sheet of paper, the stack would reach beyond the moon, beyond Mars, beyond the outermost planets in our solar system, and continue for billions of kilometers into the void of interstellar space. And remember, each of these stars is a sun, many with their own system of planets. Some of these planets could be teeming with life, a testament to the boundless possibilities that such a vast universe holds. So, when we talk about astronomical numbers, we're not just talking about abstracts. We're talking about the fabric of the universe, the stars, galaxies, and potentially the life that it holds. These vast numbers are a testament to the sheer scale of our universe. It's a scale that's hard to wrap our heads around. But by comparing it to things we know and understand, we can begin to appreciate just how expansive the universe truly is. With these comparisons, the vast number of stars in the universe comes into focus. The age of the universe and the rate of star formation are key to understanding the number of stars in existence. So let's start with the age of the universe. Scientists estimate it to be approximately 13.8 billion years old. This is based on observations of the cosmic microwave background radiation, the oldest light in the universe, and other cosmological data. Now you might wonder, how does this relate to star formation? Well, stars are born from clouds of gas and dust in space, a process that has been happening since the universe was just a few 100 million years old. The rate at which stars form, however, has not been constant over the universe's lifetime. In the early universe, the rate of star formation was much higher than it is today. This is because there was an abundance of the raw materials needed for star creation. Over time, as stars have formed and used up these materials, the rate of star formation has gradually slowed. This doesn't mean that star formation has stopped, far from it. Even now, new stars are being born across the universe. However, the rate at which this is happening is significantly lower than in the past. It's also worth noting that stars have different lifetimes, depending on their size. Massive stars burn through their fuel quickly and live only a few million years. Smaller stars, on the other hand, can exist for tens to hundreds of billions of years. Therefore, the number of stars in the universe at any given time is a balance between the rate of star formation and the rate at which stars die. This balance has shifted over the universe's history, with periods of rapid star formation, followed by slower periods, shaping the cosmic landscape we see today. In conclusion, the age of the universe and the rate of star formation shape the cosmic landscape we see today. With so many stars, the question arises, are we alone in the universe? The sheer number of stars suggests an abundance of opportunities for life to emerge elsewhere. But how can we estimate the likelihood of encountering extraterrestrial civilizations? Enter the Drake equation. This mathematical formula takes into account several factors, including the rate of star formation, the fraction of stars with planetary systems, the number of planets that could potentially support life, and the lifespan of technologically advanced civilizations. By varying these parameters, we can generate different estimates, ranging from a lonely universe with only us to a cosmos teeming with civilizations. Of course, the Drake equation is more of a tool for fostering discussion than a definitive answer. Still, it underscores the fascinating possibility of life beyond Earth. So, as we gaze upon the night sky, remember that each star could be a sun to another world. The possibility of extraterrestrial life adds another layer of intrigue to our exploration of the stars. Our journey through the cosmos brings us back to the mind-boggling numbers we started with. We've journeyed through our own Milky Way, exploring the estimated hundreds of billions of stars it houses. We've ventured beyond, into the vast expanse of the universe, confronting the staggering concept of 2 trillion galaxies, each brimming with stars. We've touched upon the diverse stellar populations, the intriguing world of exoplanets, and the tantalizing possibility of extraterrestrial life. These astronomical figures, these mind-blowing numbers, they show us just how vast, how beautiful, and how complex our universe is. Each star, a beacon in the darkness, a world of its own, a story waiting to be told. As we marvel at the vast number of stars, remember that each one is a world waiting to be explored. So, keep looking up, keep exploring, and keep wondering. And don't forget to like, subscribe, and share your thoughts in the comments.